May we have your attention, please?
RSSB's work spans many aspects of railway life, from asset integrity to the health and well-being of people who work on and around it. One of the themes of the research programme that we manage is Perform. This looks at ways in which the railway can work more efficiently and deliver a better customer service. What you may not know is that we also have a funding and grant scheme that supports the development of products to get to a point where they can, at very least, be trialled on a section of the working railway. One of those schemes has funded 3 different approaches to the issue of very short-term planning, or VSTP, for train services. In episode 29, I talked with Maggie Simpson of the Rail Freight Group and Martin Gledo of 3 Squared about the Path Planner tool, a system that speeds up the process of creating a VSTP application to submit to Network Rail. In this episode, we'll take a look at another VSTP tool, PathFinder. PathFinder is being developed by Worldline and Alstom and is trialled in partnership with South Western Railway and supported by Network Rail's Wessex Route. To find out more about PathFinder, what it's done and what it hopes to achieve, I'm joined today by Chris Pryor, Head of Train Service Operations Projects at South Western Railway, James Hilder, Senior Fleet Control Manager at South Western Railway, Doug Short, Business Analyst at Worldline, an international IT solutions company, and Marcus Carmichael, Professional Lead for Operational Performance and Development at RSSB. With so many on the call today, I'm going to ask each of them to introduce themselves when they have something to add to the conversation. So let's start, if we may, with Marcus. Could you describe the performance challenge as RSSB sees it?
Thank you, Ant. So yes, Marcus Carmichael, Professional Lead for Operations and Performance Research at the RSSB. I lead on the Perform Research Programme as well. The Perform Programme was launched in 2018 as a response to the declining national performance that we'd seen across the network. Since then, it's been responsible for some great innovations to help the wider industry. And what we see in the VSTP competition call that we've seen are 3 really good innovations coming from it. So the very short-term planning process covers the need to amend or create new train paths, typically within 48 hours of when that train is required to operate. Freight has a great requirement for ad hoc train paths for running additional services, but it's also needed by passenger train operators as well for managing disruption. When there's significant disruption across the route, either to an individual train or due to an issue such as overrunning engineering works, we need to write new train schedules. This is on top of the other day-to-day tasks that the controller are having to do. So having a robust and clear process that enables this to be done efficiently is very beneficial in helping the network return to its normal state quicker and giving passengers better information about what trains are running, where they're calling, and when they're expected to arrive at their destination. To support this particular challenge, we launched the Dynamic Train Planning competition. What we were looking to do with this competition was fund 3 projects to streamline the VSTP process. We invited proposals to address the VSTP process, looking at how we could streamline that process and add some resilience to get more reliable train plans that could be implemented quicker with greater confidence by the controller. Having this better VSTP process helps the train service return to normal as quickly as possible.
Marcus, thank you very much for that. You mentioned in their job of the train controller. I'm going to turn first to Chris Pryor from South Western Railway. Could you please, Chris, introduce yourself and tell us what the train running controller does on a day-to-day basis?
Thank you, Ant. Yeah, I'm Chris Pryor. I'm the Head of Train Service Operations Projects for South Western Railway. The train running controller is responsible for the real-time delivery of the train plan over the Wessex route. The role of them is to really manage the real-time train running and also ensure that performance targets are achieved. They respond to the requirements of the train operating companies and the freight operating companies over the routes. On the Wessex route, we have not only South Western Railway, but Great Western Railway, cross-country trains, also the freight operating companies, and finally, Southern Railway. In addition to that, managing their requirements and real-time performance, the train running controllers are responsible for arranging additional services, and they do this through the very short-term planning or VSTP process. So the train running controllers take a request for additional trains from the train operating companies and the freight operating companies and process these from the start of the process, the initiation, receipt of the forms, through the actual timing of the trains to finally uploading the train path into the train running systems. The train running controllers are not only doing live train running control work and managing real-time services, but they're also responsible for processing the requests. And this can be quite a time-consuming process.
Thank you very much indeed, Chris. I'm going to turn now to James Hilder. James, could you introduce yourself, please? Describe that process and how long it actually takes you to plan a VSTP request.
Yeah, sure. Thank you, Ant. I'm James Hilder. I'm the Senior Fleet Control Manager at South Western Railway. I look after the team of planners and fleet controllers that sit within the South Western Railway Control Centre. So if we need to move a unit without a pathway and we want to get a VSTP completed, the planner will currently identify the train or the unit, should I say, that we want to move, its current location and where it needs to go. He'll then form that up on a VSTP form, which is sent to the operations team, who will then try and crew that train. That then goes across to the TRC, or train running controller, and it can sit on his desk while he works through how he's going to get the train from A to B with the crew that he's got in the timings that he has, and how he can shuffle that into the network to provide us with what our needs are. Currently, the process can take 30 minutes sometimes it can take 2 hours. It depends on how long the TRC needs to draw up the pathway we want, depending on how complex it is. And it also depends on his current workload. If we've got disruption due to an incident, he'll be focused on the disruption rather than a VSTP for a train that's in a depot somewhere.
James, thank you very much for that. I'm going to turn back to Chris now. When there's a high volume of requests, what does that mean for managing the network?
As James said, when there's disruption on the network, the priority of the train running controller will be to manage that perturbation. So if there are VSTP requests, they're actually going to be delayed, or it has an impact on the quality of the output the train running controllers is producing. Some of the requests, as James said, can be very complex and take quite a long time to process. So, for example, if there was a freight path request from Eastleigh up into the West Midlands, that could take 2 hours to actually process that request from start to finish, including putting that into the system. If there's disruption, it would mean that it would take longer to process that request. It could impact on our management of disruption over the network. Also, as said, if there's a high volume of requests, we can find that obviously there will be delays in processing them, which could be delays to that VSTP train being resourced from a crew or from a stock perspective. And I say, again, it could affect the quality of the submission. So when that train does finally run with its VSTP path, some of the conflicts might not have been spotted in the schedule with other services that are running on the network. And clearly, one of the objectives of the train running controller is to ensure that performance is maintained with reduced delays. So obviously, by having a poor quality or a lesser quality VSTP as a result of disruption, that's going to affect overall network performance.
Thank you very much, Chris. Back to you, James, if I may. When the train running controller has planned the train, how do they confirm the timings and what does South Western Railway do to run that train?
Yeah, so the timings and the completed VSTP information is passed back from the train running controller to SWR by an email at the moment. The planner will get the email so he knows what stock he needs to provide at what time. The email also goes to the operations resource manager, who will see what crew they need to provide and when and what route the train is taking in case there are any implications of drivers signing routes. A copy also goes to a few other stakeholders who might be watching the progress of our trains and making sure that what we want to happen is going to happen.
Thank you very much indeed, James and Chris, for, let's just say, describing all the issues, the processes that have to be gone through at the moment. Let's turn now to Doug Short from Worldline. Doug, could you please introduce yourself and introduce PathFinder?
Thanks very much, Ant. I'm Doug Short. I'm a business analyst working at Worldline, mainly specialising in timetable planning, stock and crew resource management systems, and reference data underpinning them. Worldline, as a supplier, has a kind of heritage for planning products going back to British Rail days. And so PathFinder as a project piqued our interest because it was instigated by the RSSB Dynamic Train Planning competition. launched as part of the Perform program that Marcus described earlier. And that was great, as it really gave a real boost to looking at making VSTP process and system improvements in collaboration with South Western Railway, Network Rail, and other stakeholders across the industry. So in response to the dynamic train planning competition, we formed a consortium with us, South Western Railway, Network Rail Wessex Route, and Alstom, just to bear our expertise in Worldline for planning systems, along with Alstom's Mars automatic route setting system and expertise, which uses artificial intelligence and automation to replan and set train paths through signalling areas. So the approach we took was to bring that artificial intelligence and automation expertise along with our existing planning system expertise and business input from Chris, James, and their colleagues to form a much more collaborative and streamlined system, which in time became PathFinder. The approach that we took with PathFinder was to try to make a much more collaborative system. So where James and Chris have described, the current VSTP processes involve a lot of manual communication, manual input into systems, telephone calls and requests left on desks, and those process handoff points between different organizations and different stakeholders. So to try to relieve some of that and reduce manual input and streamline that whole process, the system starts off by allowing effectively any stakeholder with the relevant rights to make a train path request on a VSTP basis. So that may be a very simple outline request with maybe just an origin, a few key way times and locations, and then a destination without all of the fully complete details that you'd need for a train schedule to get it from origin to destination. That outline request will then be passed to the Alstom component of the solution, which will complete any missing details that are needed to form a completely valid train schedule, and will also carry out conflict detection and adjust the train path to avoid any conflicts with existing planned train services on the network already. So the outcome of that should be a completely valid train path with all intermediate locations, running lines, platforms, times, and other details, and it should be completely free of conflicts with other train services that are already planned or running. Also, within the system, effectively any user from any organization or site can see those plans as they're being developed. So rather than just seeing the output, as James described, as the final train path that then needs to be resourced, those plans as they're developed can then be visible to everybody, and the stage that they're up to in the process, whether they're draft or they've been planned to an extent, can be seen so everyone has a clear view of plans as they're developed collaboratively. We also recognized that integration with stock and crew resource management systems is a definite gap in the current processes and systems. So we've developed an interface to allow those candidate draft train paths, while they're being created in the system, to be sent off to a stock and crew management system external to PathFinder, just to allow those fleet and crew resource managers to consider a train path, compare it with their resource plans, diagrams and allocations, etc., see if they can resource it, and then send back an approval or a rejection based on that, just to then confirm whether the train service as it's outlined can be delivered as planned, or if it needs to be adjusted and replanned because the resources aren't in place to deliver it. So that should give us a much more robust plan as an output, because we've got that reassurance that the train service as described can be delivered once it's being communicated to passengers and freight customers. Throughout all the stages in this process, we've also got a fully integrated workflow management system. So through all of these stages, we trace when a request has been submitted, when it's gone for these various checks and retiming, etc. And then we also have a full approval system to allow the operator concerned, or if it's a train path that's being collaboratively put together by different operators, they can give their approval. In terms of approvals, currently, if you have a train service that runs between different geographical areas and across areas of responsibility for lots of different operation centres, that may require several train running controllers to coordinate putting that path together between them based on their local knowledge of local geography. Currently, that's done with a lot of phone calls and a lot of notepads on desks. So we have approval stages in the workflow management system to allow each of the train running controllers to see the train paths as they're developed and then they can approve different sections of those train paths for each of their different areas. So it enables them to plan and approve a train path that may cover the length of the country collaboratively between them. Then once all of those approvals are in place, we've developed integration with current industry systems, so the existing mainframe systems that manage on the day running, for example. So once all of the approvals in place, we have a fully defined train path, and we know that we have resources in place to deliver it. That can then be published off into the wider network of industry systems for communication to passengers, freight customers, and other rail organisations.
Thank you very much, Doug. It sounds like a very comprehensive and well thought out solution. As we know, the Dynamic Train Planning Innovation Competition supports solutions towards actual usage. Where is PathFinder today?
So the stage we're up to now with PathFinder is we've created a prototype demonstrator system, which shows that we can create and automatically generate a fully valid conflict-free train path from initial request through to publication to test instance of the wider industry landscape. And we've demonstrated that with Chris and James and Marcus and other colleagues in testing and demonstration sessions. So we've shown that we can automatically create and deconflict a train path if we have the underpinning geography reference data to support that. One of the main challenges we've had is creating the reference data that's needed for the system to automatically generate those train paths and carry out conflict detection. And there's a wider industry discussion that needs to be had of where we source that geography reference data for other areas on a wider basis to enable PathFinder rollout for different areas. There's very much a kind of gap in the landscape of industry reference data, which has been recognised by the RSSB Rail Technical Strategy, other initiatives such as the Network Rail Industry Timetable Technical Strategy, and other industry work going on, of looking at where we can put together that master set of data and then how we then share it through data sharing platforms such as the Rail Data Marketplace and other integration platforms that are being developed, so that really as an industry we can exploit that data to its best potential. So I think PathFinder in its current state is one of those examples where if we can as an industry put together those master sources between us and then work out the best way to share and exploit that as an industry for shared benefits for suppliers like us, for industry bodies such as the RSSB, organisations like Southwestern and Network Rail, and then ultimately passengers and freight customers, then it's an example of where that roadmap can take us in terms of new and innovative solutions.
Thank you very much indeed, Doug. It sounds like, amongst other things, RSSB's work on big data and general industry collaboration on sharing the data that's needed is going to be a very important part of taking the whole thing to a network-wide solution. But concentrating on the test area at the moment, can I turn back to James and Chris and tell us what's been your reaction to PathFinder?
Thank you, Ant. Our reaction to PathFinder is we've been very impressed by its capabilities. Obviously, we've been working with Worldline and Alstom throughout the development and seeing the capabilities. One of the first things is that we've seen is the streamlining of the process, so the ability to make the request and for the visibility of that request to the train running controller. The second thing is the ability to time trains is very quick. The fact that the timing points can be input very rapidly. That it has industry data in there that is recognised and quickly process the request and can detect the conflicts. And I think we witnessed this with the demonstrations that we've done, that we're finding a VSTP path through the Southampton area in the busy evening peak. A process which could probably have taken half an hour beforehand would take a matter of about a minute to identify and process and time the train through that section and give that response back and give us the visibility to start planning the trains. So, in terms of what we've seen, the end-to-end process is very good. The robustness of the process is excellent. We've contributed to that process, but that is reflected in the system. And the response back that we've got is one that, when it has been reviewed by the train running controllers, has been validated by them as being the optimum solution. So, it's as good as the human eye would be, or the human brain would be, in terms of processing this data. And that will then feed into our stock and crew systems and enables us to actually plan things a lot faster from the South Western Railway side. A great approach, good collaborative working from our South Western Railway Network Rail with Worldline and with Alstom to actually deliver the product. And it has set out and has delivered what we achieved to do in terms of reducing the processing time and improving the visibility of train paths on the network and improving the quality to a high standard as well.
Thank you very much indeed, Chris. James, have you got anything you'd like to add in there?
Yeah, just again to say that what we demonstrated looked very good. I think Doug covered it when he said that it gives you the ability to view where you are in the process of a VSTP, and the fact that it removes the idea of there being bits of paper on people's desks and emails sat in inboxes. Anybody can log on to the system and identify how far through the process your VSTP is. Has the TRC started looking at it? Is there crew for it? It's the clarity without having to go around asking people, especially for us with our control being split between Waterloo and Basingstoke. You don't always have the ability to walk over to the TRC yourself and ask the question. So if you've got it in front of you on a piece of software, then that's a big jump and improvement.
Thank you very much, James, Chris, and Doug, for sharing your insights today on the PathFinder solution. Let's hope we can see it rolled out across the network and improve things both for the train operating companies, freight operators, and all our customers. Finally, I'm going to turn back to Marcus just to talk briefly about how important the research, development and innovation funding has been for optimizing train operations.
Thank you, Ant. I think everybody in industry understands the need to optimise our operations. And what we've seen, though, through the pandemic and with the industry reforms is that need has been supercharged. Research and development allows us to investigate new methods and new technologies to unlock the potential benefits that are available to us on the railway. But that R&D needs to be structured. It needs to be coordinated to have some coherence and make sure we work towards that common aim, and all of that R&D is pushing us in the right direction towards a better, safer railway. The rail technical strategy provides that framework for us. It helps direct the research in the way that rail sees itself evolving in the future. And we launched that strategy 2 years ago with close collaboration with some very senior figures in industry, from train operators, from Rail Delivery Group and from Network Rail. Part of industry's vision for 2040 is to be able to deliver demand-based operations where trains can be planned or replanned to meet the customer needs. Now, the Perform programme has to fit within that framework. It has to create a well-thought-out, structured, fully funded programme to help progress the research towards that vision. And that's where the dynamic train planning competition fits into it. And the solutions developed through this competition are all part of that work stream towards creating more dynamic train planning. More efficient VSTP processes will help deliver better service recovery and streamline the processes for running additional services to meet our customer needs. So having that well thought out, structured, fully funded programme gives industry a focus to be able to drive through the changes it needs to enhance its operations whilst remaining separate from the day-to-day running of the railway.
Thank you very much, Marcus. Thank you, Doug, James and Chris, all for your contributions today. I hope our audience has found some food for thought, albeit perhaps for a little while in the future. Thank you all for listening. Stay safe and keep well.